Welcome back, everyone. We're now at the challenge pitch session. We received over 90 submissions from individuals and teams, and now we are at the top 10 finalists. We'll kick it off with our first pitch from Deni Maric, and his design was an Aeromaric, a hydrogen-powered airship concept for medical and vaccination response. Let's check out his pitch.
Hi, I am Deni Maric, and thanks for giving me this opportunity to showcase you my latest baby, hydrogen-powered airship concept for medical and vaccination response, aka Aeromaric. To begin with, I want to shortly introduce myself. I got engaged into engineering since an early age because my father was a good one and I wanted to be better than him. While my mother kept telling me I should be a doctor, father always reminded me that doctors might be better with ladies, but engineers work with models. This is what engaged me at the age of 15. While inspired with the October Sky movie, I was building my own rockets and cooking propellants in my mom's kitchen. Later on, I graduated with 2 master's degrees. Yet all that hard work did not get me into rocketry. But here I am in front of you. That should mean something as well. Well, it is not really interesting to talk about myself, so let Aeromaric talk itself through instead. In short, Aeromaric is inspired by the pure desire to help others and to prove that even though it is still hard to imagine no-emitting aviation industry, it is possible to make flying vessels with no harmful emissions. As COVID-19 pandemic started at the beginning of last year, it kept turning the world upside down. Take current case in India and Brazil, highly populated developing countries with low infrastructure. As the pandemic hit the major city, it started spreading toward the rural areas which are difficult to reach and therefore does not have an easy access to medical care. As vaccination and the lockdowns are currently our main responses, couldn't we imagine something that make it simple for them? The inspiration came spontaneously, as I argue upon one documentary and if something better can be done for doctors seeking to help others. That night I couldn't sleep. I knew idea is bigger than me. About 3 weeks later, Aeromaric came out and you are currently looking at it. Why Airship? Well, I don't know if you noticed, but batteries are extremely challenging for flying. They are simply too heavy or lacking the duty cycles at this point of time. This is where hydrogen came along really nicely, providing me with the range I needed. Unfortunately, since none of you forgot about Hindenburg disaster, I had to be creative and playing it all around methanol as a hydrogen storage and helium as inert lifting gas. The compromise cost me in performance a bit, but hope overall you could see the benefit. Acceptable gravimetric energy density, significant increase in safety and simplicity, methanol is considered as biodegradable. All this made it easier to design and easier to put doctors on board. Aeromaric utilized 3 independent hybrid electric powertrains with the high temperature PM fuel cell technology, which operates at the temperatures of about 180 degrees Celsius with assumed efficiencies of 45%. Look at them at constant batteries. As long as you purge gas into them within the right conditions, it should give you electric energy and the heat due to losses. Well, one of the biggest ideas in this project is reusing the rejected heat from the fuel cells to heat the big balloon. This simply increases efficiencies. Tailpipe emissions from the fuel cells represent no harmful emissions and are therefore considered as safe to breathe. Controlling the mixture ratio of hot and fresh air, you would control the temperature and the lift. In few words, I would try to benchmark you this project as it is. Due to few engineering tricks, you are now looking into the miles per gallon equivalent fuel consumption comparison, showing one of the main benefits of Aeromaric. On contrary, due to heavy powertrain, the payload capacity is reduced, but acceptable. Hope this leaves us with some time for questions, or feel free to contact me later on. As you could notice the green line and the red cross on the design, it is here to clearly communicate my vision of this project. Noble gas for noble purposes. Thank you.
Thank you, Deni. That was a super cool concept, an absolutely relevant topic, and also an important sector. Overall, a really beautiful execution and documentation. So well done. Now moving on to our next finalist pitch from a team represented by Nelius. They're designing a new type of drone designed to fill the market void for long-range deliveries. Let's check this one out now.
Good day, my name is Deni.
And I'm Nelius van As, and we are the directors of Tonel and the creators of the DNLR 101 drone. Like many of you, we have entered this competition, not only to have our ideas recognized, and more importantly, critiqued, but because we want to contribute towards a greener future.
Due to our busier lifestyles and the global pandemic, people have changed their buying habits and will more likely purchase online than visit stores or a place of business. The fact has inspired companies like Amazon to invest heavily in delivery drone technology. But what about medical operations or military?
While the DNLR 101 UAV wasn't necessarily developed to replace the traditional transportation methods just yet, but with its 10 kilogram cooling payload, range and speed, hospitals and doctors can gain quick access to organs for transplant patients and or medications such as antivenom. The range allows it to reach remote villages to deliver COVID-19 vaccines or military supplies and support items.
Why did we not just go electric? Firstly, the battery systems available today are heavy and unpractical for flight, whereas hydrogen is lighter. Furthermore, lithium mining is devastating to the environment and human rights, with claims of child labor and unregulated practices.
By using a solar AEM electrolyzing system to create hydrogen, we can achieve a true emission-free delivery system. Not only that, but the payload is kept cool by the hydrogen during flight. The same hydrogen is used to fuel the turbine engines, and due to its high combustion propensity, results in more range and higher speeds, up to 600 kilometers per hour.
Once fully developed and in operation, the second step is to build a network of refueling stations across the world, allowing for delivery anywhere in the world, and not just the world. The construction methods, materials, and hydrogen propulsion even allow for the drone to do deliveries to the International Space Station. The DNLR 101 will prove that the sky is not the limit.
Hydrogen's low density, high specific heat, and thermal conductivity make it a superior coolant for this application. Plus, it's abundant and therefore relatively inexpensive. While on the topic of money, unmanned aerial vehicles, more popularly known as drones, are expected to generate $82 billion of investment and economic growth by the year of 2025, along with creating more than 100,000 new jobs.
Despite recent regulations, the Federal Aviation Administration has already issued hundreds of waivers to companies interested in commercial drones for delivery. While it's easy to see how these drones will impact most industries, they will have the greatest impact on supply chain and logistics.
Ultimately, while the drone industry is expanding, why not do so in a truly sustainable method? While the DNLR 101 is still in its concept stage, we hope that the next time we speak, we can showcase its first flight.
Thank you for your time and joining us on our journey. Enjoy the rest of your conference.
That was a really cool one as well. Honestly, well done, team. And I love the sentence, hydrogen shows that the sky is not the limit. That's exactly the right kind of attitude. So well done, guys. Super cool flying machine. Last but not least, in our top 10, we have another team represented by Zain Farhan, and their design is a hydrogen-driven offshore solar radiation management system. think the video will tell us a bit more about what their idea is.
Hello everyone, my name is Zain Farhan, and in this short presentation, my teammates and I will be sharing what we've done for the Enapter challenge. I'd start by introducing my team, which consists of Simran Masood, myself, Talha Ansari, and Carlos Miguel. All of us have one thing in common, and that is the desire to pave the way for a sustainable future. So when we came across the Enapter challenge, we were quite excited, and we created a simple plan. We knew that we had to design an innovative system which would not only highlight the most characteristic applications of hydrogen, but it would also fight climate change. And we made sure that we could get as creative as possible throughout the whole process. This resulted in the creation of the hydrogen-driven solar radiation management system, SPF Infinity, or as we like to call it, the Earth's sunscreen. So to give you a fair bit of an idea about our project, I'd like to show you a small video.
Climate change, one of the greatest threats our humanity has ever faced. The crisis of our time has already started to manifest in our environment, fundamentally changing the world around us. Do you also believe that we humans have ran out of time to solve the climate crisis? Well, not on our watch. We believe that there is still hope on the horizon, and if we act fast enough, we can stop what seems imminent at the moment. We propose a unique solution to combat climate change, a multi-purpose offshore platform infused with the promising hydrogen-driven marine cloud brightening system. MCB is in principle a solar geoengineering technique that aims to artificially reflect the incoming solar radiation back into space. How it works is actually pretty simple. A hydrogen-powered vessel operates in the ocean, spraying seawater aerosols at the lowest altitude clouds, enhancing the ability of the cloud to reflect and promote its longevity. This results in producing a localized cooling effect, thereby neutralizing global warming.
Now, to put it all together, we have come up with an idea to design an offshore multi-purpose platform whose job is threefold. Firstly, to generate electricity from renewable energy sources like solar and wind. Secondly, to produce and store hydrogen on-site using Enapter's electrolyzers. The platform could also act as a long-term energy storage bunker. Lastly, to provide quick refueling for MCB spray vessels or passing commercial ships, helping the transition of global shipping industry to green hydrogen. Our system can be feasibly deployed in strategic locations like the Malacca Strait, the China Sea, among others, enhancing the global effect of MCB to reduce the temperature increase, buying us more time to reduce the greenhouse gas emissions.
The video pretty much summed it up. I would just like to elaborate on the vessels. The concept behind the design of the vessels is called marine cloud brightening. We want these vessels to run on hydrogen fuel, produce seawater aerosol, require least amount of material for manufacturing, and have the ability to run from a remote location. These vessels have one intake for air and one for seawater. These flow through the intakes through a set of filters into the mixers from where the aerosol is released into the atmosphere using the chimneys. Here is a diagram of the mechanism that represents how the ship works. Now I would like to forward the virtual stage onto Zain. Thank you very much.
Before we end, I'd like to share some interesting numbers that we came across. So the initial feasibility report showed that this project would have a 10-year payback period. And most importantly, if we deploy 188 ships upon the 8 locations that we mentioned in the video, we would be able to keep the Earth's temperature steady in the current scenario. So thank you for being such patient listeners. I would request you all to please scan this QR code and gain access to some interesting infographics and reach our profiles so that we can connect and work for future collaborations. Thank you.
Wow, I actually had goosebumps during that video, and that was an absolutely inspiring pitch a solution as well. What a fantastic and beautiful solution to fight global warming. So that's a wrap on our first 3 challenge pitches. It's an amazing way to kick this day off. We still have 6 more to come today, actually 7 more to come today. So definitely stay tuned for the other ones. These are just a glimpse of the world if it were powered with green hydrogen solutions. So have fun, and I'll see you guys later.